always tell you what I want to say. Baby, did you feel the same? I remember laughing and playing games.
Let us discuss the role of a structural engineer. The primary role of a structural engineer is to ensure strength of the members of the building. Different members, based on its position, will have different kind of forces developed in that. Basically, the load acting on the members, for example, the dead and live load is first applied on the slab, and the slab bends. The slab bends and transfers the load onto beams, and beams to columns, and columns to foundation, and foundation to earth. So in this process of distribution of load, certain forces are developed in the members based on its location. Slabs subjected to bending experiences shear force and bending moments. Same is the case with beams. It will experience bending, so it will have bending moments and shear force. Columns is predominantly a compression member. It is also subjected to compressive force, and due to the frame action there will be bending in the column as well. So based on its position and location, different members will have different forces developed in it, and the force is the result of a load acting on the building. So load and forces are completely different, and by doing analysis, what we are doing is we are applying the load and getting the force developed in the members, and we are going to design the members for these forces developed, and the analysis gives you the forces developed in the members. So primary role of a structural engineer is to ensure the strength of the building. The members should be capable to take these forces. It should be able to withstand these forces resulting due to the loads. So that is the primary role. You need to ensure the strength. The slab should not fail in bending. It should not fail in shear force. The same way the beam should not fail in these forces. Column should not fail in compression or bending. The footing should not fail due to the load, the force developed due to the load. So that is what we ensure by designing. When you say that you are designing for strength, these aspects are taken care. So how do we take care of these design? We will elaborately discuss it in the subsequent modules later. Currently, our intention is to understand what is the role, and one of the primary role is to ensure strength of the building. Now, another important role of a structural engineer is to ensure stability of the building. Ensuring strength is one. Say you ensure the strength of all members, and after that the building overturns. So what is the use of ensuring strength? So we need to also ensure that the building is stable. Now, what do you mean by stability? So there are different aspects of stability. One is overturning, and the best method to check for overturning is to ensure there are no negative or uplift in your building. So check for the reactions and ensure there are no uplift forces. Generally, a building as a whole may not be subjected to an overturning, especially when the building base dimensions are larger. Tall and slender buildings are liable to subjected to overturning. Otherwise, building structure as a whole is not that much susceptible to overturning. Also, say in case of soil settling or something like that, so you need to ensure that the soil report is all fine, it's all done, your building is on really good earth, you are not having differential settlement chances. So you need to ensure your building is foundation is resting on hard earth. So you need to ensure soil report is done and all that. So it's a structural engineer's responsibility. If the soil settles on one side of the building, again there is a chance of overturning of the building due to collapse of soil. Another important aspect in stability is controlling sway. So these are mentioned in IAS 456 clause number 20.1 to 20.5. So please go through these clauses in IAS 456. We have provided a copy of IAS 456. So look these clauses, understand it, and then if you have any clarification required, you can get back on that. So the main control of sway is under wind loads. your total deflection of your building. So where do you get the total deflection due to lateral load? You can get it from ETAPS after your wind load analysis, which we will see later. So after analysis, your wind load deflection should be within L by 500. That is the height of the building by 500. It should not exceed this value. So if your building is say 4 meters tall, so 4 meters into say 3 meter each floor, it is 12 meters or 12,000 millimeters. So your deflection shouldn't be more than 12,000 by 500. So this value is 12,000 by 500 is around 24 millimeters. So your lateral deflection due to wind should not be more than 24 millimeters. If it is more than 24 millimeter, then you are not satisfying the stability requirement. The sway requirement is not satisfied, and you need to either increase the number of columns or introduce shear wall or reorient your column, all that, and then ensure your building is deflecting less than h by 500. So this is controlling sway. So mainly under stability you have two conditions to check: overturning and sway. Now I will discuss some local chances of overturning. So this is not overturning of a building as a whole, but the local member, say beam, could overturn. So for example, you have a lintel here. Say you have a room and you have a corner window. So a corner window means a window at the corner of the room. So if I take a section or elevation, it would look like this. So you will have a lintel beam here, and then there will be brick on top of it, and then you have a load bearing, say a slab bearing onto the wall. Say this is not a framed structure, this is a load bearing structure. So these loads are going to come onto this lintel, and this lintel is going to overturn because it's not supported here. Say one of them will be a cantilever and the other one will be supporting on that cantilever. So the cantilever one will not be stable because it is supported here, and there is an imbalance force on top of it due to the weight coming on top. So until and unless you anchor it into a column here, or you give adequate length here to balance the overturning moment, your building is not, or this beam is not stable, it will overturn. So you need to give, if the lintel span is say 1 meter, you need the back anchorage also sufficiently more than 1 meter to ensure it doesn't overturn. It will develop an equivalent or more balancing force in the other direction to ensure this weight into this distance is more than this weight into this distance. So if you don't do this, your beam is not stable. So you need to look around for such instabilities in your building. Until and unless you look around while scheming, you will not capture this. So your scheme should be robust. You should be looking for instabilities like this prior to start to model and all that. So scheming is very important. So you can either plant a column here and ensure there is a support for this cantilever beam, or give adequate back anchorage so that this lintel is stable. Now similar is the case. It's a cross section at a window. You have a cantilever projection here, and this cantilever will produce a torsion in this lintel. Even if you have designed this cantilever for the top moment, and even if you have designed this beam, lintel beam, for the moment coming on this and the load coming on this, since this is a cut lintel which is resting on top of the wall, and since it is not connected to column, it is just resting on top of a wall, this is subjected to overturning. Since it is tightly packed between the roof beam as well as the brick wall here, it is not overturning after construction. But during construction, if you look at the construction sequence, we will first build the frame. So the frame is built first. The columns, beams, foundations and all that, it is built first, and then you brick up. So your walls are built next. Then you will put the formwork for the cantilever and lintel together, and then construct that. And if you remove this formwork prior to putting this wall, that is the fourth one that you are going to do. So if you remove the formwork for the cantilever slab here prior to casting or constructing this wall here, then this is going to overturn. So you have to put a note in your structural drawing indicating this very clearly, that the shuttering to the slab can be removed only after construction of the brick wall above. This tightness between this lintel as well as the roof beam is in fact stabilizing that area. So until and unless you do that, your design is not right. You can always pass on the responsibility to construction engineer, saying that he should take care of this. But if you think it's a shared responsibility, until and unless we put this note, our design is not working. Our design strength point of view
alive, can't put me in a box. I redefine any definition you got. I am the tiger.